Welcome everyone to another quick PS3 live stream here on our MoreLife channel. Now that we have our tiny little Linux distribution in top-notch shape, we can go and do the fun things that I always promise to continue with more shares, likes and subscribes. And today I made PS3 T2 Linux a whopping nearly 4% faster. And the sad thing is, PS3 Linux could always have been that 4% faster, just Sony and the Linux developers obviously never wanted it to, right? So what is the issue? I implemented that proof of concept already a while ago. And the issue is, of course, that Sony did not want developers, homebrew and professional Linux developers have access to their RSX, NVIDIA RSX, because obviously the obvious thing they expected, and they kind of were right a bit, that if you have too much access to the NVIDIA GPU, you sooner or later could DMA, direct memory access, transfer all the hypervisor secrets out of there. That was probably, as far as we all understood, the main reason why Sony never wanted to give us more access to the RSX. Of course, that ship sailed over a decade ago. People nonetheless reversed all the PS3's secret. Anyway, because Sony initially, when Sony surprisingly initially had official other OS support, and Linux was running with Sony's blessing, they even wrote here the Linux frame buffer driver in like 2006, Sony Computer Entertainment Inc. 2006, 2007. PS3, this is the source of the upstream Linux kernel frame buffer, and I said it before and I will quickly outline it today. The problem with that is, due to the way the RSX is built with all the cell interconnect and buses and stuff, the speed of the cell processor is documented here in the PS Dev Wiki, for example. The problem is that the cell, so you have the quarter gigabyte XDR memory here, and then the quarter gigabyte of GDDR3 memory. The XDR is connected straight to the cell processor. The other quarter gigabyte is local to the NVIDIA RSX. And due to all the buses and stuff and locality, access speed varies widely, right? So the cell processor can read XDR at a whopping nearly 17 gigabyte a second, write it even faster at nearly 25 gigabyte a second. However, the cell reading from the GDDR NVIDIA RSX frame buffer is extremely freaking slow, like 386 kind of, 486 kind of slow. This is not a typo. You might expect that it's truly a typo. No, it's not a typo. It's just the way the interconnects work there. And that is freaking extremely slow. While writing to the RSX local GDDR3 memory is still okayish fast, or decently fast, is at 4 gigabyte a second. And only most likely due to this, because reading the freaking frame buffer is so damn slow on the PS3, the Sony employed engineers did here some trickery in the frame buffer that, in my opinion, was superfluously unnecessary and stuff. So instead of mapping, so what the Linux frame buffer always has done with Sony's implemented blessing is they don't directly use the GDDR3 memory. You could always map it, you could always access it, but the Linux developers employed by Sony have intentionally chosen to hide this extremely freaking slow read. And in my opinion, this was a really stupid decision. So the problem with that is, you see that here, that they have a kernel thread, this is PS3FBD. So this is here a kernel daemon, a very small kernel daemon. And what this does is, this is waking 60 times a second, basically on this. This is hardwired to the vsync interrupt. So 60 times, or whatever video mode between 50 and 60 hertz, whatever you configure, this kernel thread wakes up and syncs here the whole frame buffer using DMA. Yes, using DMA, but this kernel thread is has always costed you 4% of the Well, if you run on HD ready, full HD also, then this is costing you a whopping 4% of all your PS3 performance. I noticed that years ago I implemented, so what is the solution? My solution to that is we don't want this anyway. We don't want this for multiple reasons. I mean, not only wasting nearly 4% of your power PC performance, and then the other issue is, because this is implementing double buffering, this is also wasting you 9 megabytes of system memory. And remember, we only have a quarter gigabyte, right? Only, thankfully it is more than 640K. So what double buffering is, so what the Sony engineers and kernel developers have done there is like, reading from the screen is slow, so then let's double buffer it, right? They create a permanent back buffer, which they allocate 9 megabyte of precious XDR memory, which is quite a significant amount of your only 256 minus some overhead XDR memory. And the Linux frame buffer here is always mapping, so that is XDR here. So they have an DDR, this is a NVIDIA local RSX memory, and an XDR PS3 cell local memory. And they allocate that on boot up. That is in another code that is in PS3 platform init. So they allocate whatever you boot with. Default is 9 megabyte, you can tweak it. So you are not only wasting 9 megabyte, but you're also wasting CPU performance only to hide this abysmal slow 16 megabyte read performance. And before you now say, yeah, but René, there are good reasons, and obviously 16 megabyte is extremely freaking slow. Yes, it's extremely freaking slow, but my argument would be just don't read the freaking frame buffer. You don't need this. You really don't need this. You don't need this in games. You don't need this for X-windowing system. This was extremely stupid. While it is nice that the Sony developers at least implemented for us memory DMA, well, the hypervisor does it. So why is it so freaking slow? So at least they implemented us frame buffer blit. Thanks for that, like LV1 hypervisor GPU frame buffer blit. Didn't give us much, but at least it was one DMA away, because what this does is, this is changing this for the RSX to pull in the data, and that can read, that is reading. So the performance of the frame buffer is then always this high numbers here, which here is high, but memory wasting. And the RSX can read this at whopping, so that is still faster than like writing 4 gigabyte a second to the GDDR RSX memory. So the RSX can, through the buses, through the interconnects, read DMA, direct memory access, read the XDR cell local memory at nearly 16 gigabyte a second. So that is what that is doing, right? So with a refresh rate of your display, it is DMAing, telling the, like, calling the hypervisor, hey, GPU frame buffer blit me, here's this buffer. So far, so good. So the problem with that is not only 40 to 60 times a second calling into the hypervisor, which we see as quite some overhead, and then it's also waiting for completion, right? So it's not only super slow calling into your hypervisor, but then even slower waiting for its completion, because they don't use asynchronous notifiers here. So the Linux kernel stalls and deadlocks for the whole duration of this GPU blit. For the hypervisor programming the ring buffer of the NVIDIA RSX, the NVIDIA RSX doing the blit, which takes some nanoseconds or milliseconds, whatever, and then finally returning here to the Linux kernel. And the bandwidth alone is massive, right? So if we have 1920 by 1080 or whatever, multiplied by 4 bytes, that is already, so one whole frame is already 8 megabyte, I believe. So that is just the frame buffer data, right? And then multiply that with up to 60 times a second. I hope I don't have any typos in there. Divided by 1024, 1024. So that is a constant memory bandwidth of potentially 474 megabyte a second, if I didn't make any miscalculations. So while this is a massive background, so this is just, even if you have a static frame buffer image like this, and nothing is changing with Sony's other OS PS3 Linux, you always had a background bus load of 474 megabyte a second of just copying the frame buffer to the RSX, even though nothing, not a single pixel changed. Plus, the overhead is measurable, right? If you run any PS3 Linux from the last decades, you have here a kernel thread, which obviously my Linux doesn't have anymore because I just patched it finally away for good. So usually you have a PS3 FBD here idling around 3 to 4% CPU load, right? Which is obviously crazy, especially given that the performance unfortunately is not that high with a 30 or whatever stage pipeline, non-speculative executing. So what does my patch do? So that is the original code, right? The original code allocates this memory waste. So to summarize that, our Linux is now performing 4% better, nearly 4% better. I think it is 3 point something percent. I have it here on our Discord somewhere. 3.23 whatever, obviously, wherever that was. And the other more important thing is freeing 7 megabytes. So we can't free all because we still need at least 1 megabyte for the NVIDIA command ring due to the way the hypervisor calls are implemented in work. And practically, I think most hypervisor versions will not, due to the security vulnerabilities that Sony work around it. I would check if we can allocate the RSX buffers with less than 2 megabyte. So long story short, from 9, I reduced it from 9 to 2. Less than 2 would need checking if it works, maybe it doesn't. So for me at this point, it's not worth to check whether we can save another megabyte. And last but not least, so yeah, nearly 4% better performance for all, not for graphics, 4%. So truth be told, graphics are slightly slower because instead of splitting everything but slightly slower for similar performance, right? And enabling us the way, so the difference is we now write with 4 gigabyte, we write and copy everything to the frame buffer with 4 gigabyte, which is still freaking fast, instead of previously 25. But you do not split that much, right? That is, it's not like your PowerPC cores are not that fast to sustain splitting alpha blending graphics at 25 gigabyte a second anyway. So we basically gain what we need most. We need more CPU performance, right? So if we compile stuff from sources, for example, building here AmpUtils, because I built this a couple of times. So that is nearly about 4 seconds faster, right? 1 minute 48 seconds to 1 minute 44 seconds, right? So this comes down to 3.23 whatever percent performance improvement. And that shows with everything, right? Multimedia, audio, video, 4% improved performance. We further decrease the bus utilization. We obviously improve idle temperatures. We improve background bus utilization by half a gigabyte a second, as just calculated. And we need the memory anyway for more 3D graphics, right? We even simplify the frame buffer, so we delete a good load of obscure code here in the frame buffer driver. I started this 2 years ago, but it wasn't fully working. Only last night I further went through and made it work more. Work more here so that is a patch. I moved it here now to 666, I believe, a revamp patch. So that is a patch as outlined here. Free system memory, bandwidth, simplify the code. by drawing into the RSX DDR frame buffer directly. It should work with even other OS without ++, with the official Sony stuff. I should test that. Maybe I should dedicate one PS3 to run official other OS, not only all my other OS++. So we remove all this stuff, right? So this stuff is mostly code deletion, which is obviously, as we know, always good. Is kicked, task structure, XDR, so all the XDR frame buffer size stuff, syncing the image. Here, all the blitting here in sync image, no longer blitting. Here, mode validation, all the XDR stuff. More XDR line. We remove more XDR stuff later. I have this staged. More deletion, right? Clearing the DDR frame buffer memory. Delete. Here, PS3 frame buffer background daemon thread. Delete. Then, whatever that is. This is the vblank stuff is kicked. Wake up background task on vsync interrupt. And I know we actually gain of actually utilizing real RSX NVIDIA VRAM. So I changed this from currently from video memory size that was 9 MB to 32. Theoretically, we need an option for that. I do not, theoretically, we could allocate all, but I save this for later date. For now, I changed this from 9 MB system, of which are 8 MB, nearly like a little bit less usable in practice due to the command ring FIFO stuff. I changed this to 32 real VRAM instead of pseudo fake VRAM. The rest will remain VRAM swap to use the remaining RSX memory as swap. So that still works. Here, GPU command buffer, that is here, the GPU command buffer start of vMemory. So as a start of vMemory, whatever. Actually, you know what? Probably, anyway, details. I just realized I still have a little bit of tiny mode setting glitches. I just realized maybe that is GPU FP start to be done in a future video. Yeah, K-thread creation here, that was a background thread of blitting this stuff, wasting nearly 4% CPU load. Here's a cleanup of module removal, unregistering the frame buffer, and here stopping the kernel thread. And that is the top on top. This is further cleanups here of even more mode XDR memory mode stuff of further cleanup. It's still not 100% perfect. So I had this working 2 years ago or so, a previous video. At that time, mode setting was broken. Tonight, last night, I finally fixed mode setting to work more. It's still not perfect. Maybe that is the, actually now I realize the command. I thought it's at the end. I might just realize it's maybe at the beginning. I need to check that. And yeah, I'm thrilled, obviously, that speeds up everything even more, right? The current highest performance, like basically T2 Linux as OS performance never was that high, that amazing, even with, so this is a retail, usually you see me here running my precious developer tools. But on a retail, you now have maybe a gig of PS3 SATA swap, but additional high-performance PS3 VRAM and SATRAM, so with a little bit of 32 MB of SATRAM compressed RAM swap plus VRAM. Actually, that makes an obviously even more usable system, emerging your stuff playing along at home. And next, we could also, if you share, like, and subscribe sufficiently, I also implemented as a proof of concept multi-tech command queuing some years ago, improving SATA performance, right? That was working proof of concept, but needs a little bit more maintenance work of actually using the right buffers and not clobbering your data sometimes. But that also yielded another 12 or so percent, nearly 12, I believe, 11 to 12% SATA performance improvements. So like if Linux experts and kernel developers actually work on all the freaking details, after a while, PS3 Linux actually becomes a whole freaking heck faster and more optimized. So yeah, what is next? So next would be, I mean, maybe the low-hanging fruit of making data performance higher, because obviously low-hanging fruits are always good, and performance also, especially for swap with so low memory. And additionally, we recently found a decade-old bug in our initID, right? So we freed a whole whopping 28 or so megabyte. So now we actually have here, is it plus minus buffers use free? So what do we have here? 160, whatever. So we have now, basically this should give us approximately, I need to check in a completely clean and stuff installation, but we freed 7 megabyte frame buffer, plus so we have 35 freaking more memory, usable more system memory with our initRD use after free fix, and another 7 megabyte of frame buffer. Goodness. Anyway, so this is the update here of optimizing the heck out of PS3 Linux, making this more amazing than it ever has been. Yeah, for RSX we still need a whole lot of more financing, so don't forget to share, like, and subscribe, maybe Patreon and YouTube membership a little bit more. I will commit this now, I would say. Probably, how do we do this best? Because we need to also, the problem with this stuff is always, I mean, even after spending hours, so the delete of course looks easy, just delete here some code and be done with it. It took me, I mean, not only did it take me some system analysis to actually realize that, and proof of concept implementing that already took probably 3 hours or so years ago, and it wasn't fully working. It took me a couple of more hours of Guru meditating, because my initial patch had mode setting broken, so that worked in principle, but the graphics, the frame buffer graphics or X graphics were garbled. So it took me a couple of more hours of Guru meditating the mode setting. It's still a little bit off. That is the thing, right? But I probably will commit this, because it's at least readable. It's just a tiny little bit off. Should probably be easy to fix with another hour or two of Guru meditation. Maybe it is simply this GPU start offset thing here. I need to double check that. I also need to think how to actually implement that then. Basically, I will leave it, because right now at home I only have a garbage display, which obviously, like debugging mode setting, if you have a dark garbage display, it's not the most convenient. And with garbage display, I mean, I have here one Sun display that doesn't support digital rights management crypto here of HDMI crypted shit, and I have here a TV kind of 720p HD ready kind of pseudo TV thing that does crypto but is a garbage display. So yeah, debugging mode setting obviously more productive if you have a proper high quality, like my NEC at work display, although decade old, at least it displays a correct video mode and timing information. That certainly is helpful. But I will commit this now. The question is, so yeah, anyway, technical details. It needs more testing, but Guru meditating that further should be relatively easy, because it's working proof of concept and it's readable now. So any mode setting thing should hopefully be simple. Famous last words. And as we know all from Linux kernel, code deletion is always good, welcome, improves debuggability. So yeah, of course there's always stuff to do, right? We should probably make this a config option, including, so this probably will be a second, like on top of this config option, this will be like, I mean, we even should change that. So this is no longer default frame buffer. That is like RSX XDR command ring buffer size, which, yeah, anyway, so we probably need to add a second, or like we probably want to, the name, anyway, we want to change that. We need a second option So XDR command ring buffer 2 megabyte plus whatever. Plus, of course, implementing boot option command line parsing for user changing the 32 megabyte to whatever. And then, of course, 3D will change everything, right? With 3D, we have set buffer, texture, dynamically allocated texture buffers. So 3D obviously will be way, way, way more complicated, which obviously is welcome to simplify this. Try a driver, frame buffer driver before we further work on this. I hope you enjoy this status report. I will go probably commit this later as a question is. I will probably unify that first because this is currently a patch on top of another patch. Maybe I even spend an extra hour or two of checking this GPU frame buffer start thing because I'm not sure if that is all, because some of the mode setting does still not 100% look right. Not entire. Yeah, anyway. You get the idea, right? The only constant is change and regressions, and all Guru meditation just requires some hours of Guru meditation. Basically, the only substitute for Guru meditation is more Guru meditation. I'm happy that you enjoy this. Let's see. Is that the constant 4 CPU usage of PS3 frame buffer I always see on top? Yeah, is it also 4% CPU for you? Please confirm. I believe it was nearly 4% for me, but yeah, it is exactly that. B. York asked what about triple buffering? Well, if you want to waste more memory, right? You might still want to double buffer in Xorg. The thing is also, if you were not careful, you basically had to disable double buffering shadow buffer in the Xorg driver. If you didn't do that, you had another, then you had already triple buffering. But anyway, all buffering should be implemented on top of whatever in user space, like doing double buffering in kernel space for no good reason. In my opinion, pretty wasteful thing. Xantefin writes, had checked, have PS3 FB idling in background on the server, but I think was wise enough to turn off completely. So yeah, if you turned off the PS3 frame buffer completely, you indeed gained the most memory. Like if you turn off PS3 frame buffer entirely, you save another 2 megabyte of system memory and also avoided this load. So if you previously built a supercomputer, I hope you disabled the frame buffer to have higher performance, and welcome everyone. Anthony loves all the P3 work. Happy you enjoy this. Damian writes exactly around 4 to, well, if yours shows 4 to 5%, that is higher than mine. But I mean, maybe my 3 to 4% was, I mean, yeah, it could actually be, I mean, that is true. If you run like full HD, it might even be 5%, because maybe my 4%, actually, maybe I should change the title. I believe 720p full HD already crap resolution is already 4%. So yeah, maybe it's even more than 5%. That is possible, yes. Anthony asks, does Wayland would add any benefit for PS3 over Xorg? Not really. The problem is we would need a mode setting driver, right? So and theoretically, so yeah, I mean, benefit is relative. The most benefit would be writing a proper 3D driver, and we would need, like, for proper Wayland, we need a real mode set driver plus preferably a alpha blendable driver. So without a proper RSX driver, Wayland will not be much fun. So Anthony asks, could we plumb the 3 driver into the Novo driver? Yes, we could, but it is complex, right? The problem is, we have 34 people. So the problem is, I said this before in private chats, which also, the last 4 weeks we made T2 Linux amazing again, right? After I neglected the non-core stuff. So the reason I can do now more of the stuff is that T2 works a treat on all architectures, including IBM mainframes that I constantly also fix for IBM. Share, like, and subscribe for some love of IBM mainframes. And now that T2 is mostly in an amazing state, except yes, we need to package Pipewire and update KDE and GNOME a little bit more. But now, and some 10,000 YouTube subscribers obviously help also a bit, now we can do the fun things, right? The problem with RSX, like when I started YouTube nearly 4 years ago, I put actually quite a week or so into RSX. Maybe in total over some summer, I maybe put already 2 weeks of getting familiar with the RSX in there. And I had this working, right? Previous videos I had partially accelerated Xorg working. The problem with that was it was mostly working except when it randomly locked up. And the problem with that is that we have a patch for that. And so what I started to do now is perfecting those patches, right? Cleaning them up, making them usable. I, of course, have this patch here archived. That is also partially the original PS3. Was it MMIO? FIFO here. That was from the original other OS hackers. And so we need to do this next. And the problem with that is, as soon as the RSX doesn't like something and it crashes, which I still don't know why it happens sometimes, which is rather unfortunate. The good thing is with this patch, which is amazing that other even more wizards than I reverse engineered all this hypervisor nonsense. So this patch from other OS++ hackers enables this here. That is enabling the hypervisor to generate graphic exceptions, meaning when the RSX has an exception, like it crashes or has some memory access error because we programmed it wrong. And so that never was documented and that never was in there. And the good thing is with that patch, we get exceptions when the RSX crashes or has memory access valid errors. You get then here somewhere a nice exception printout, which I probably should also upstream. The problem with that is we also need to enable it dynamically. So basically, maybe I should accept another PS3 donation, because what I actually would need and would not want any of my existing PS3s to do is I should probably run one with original other OS just to test how the original other OS behaves, because I don't know what the original other OS++ does. Here is a graphic exception. So you get this structure, channel ID, course, DMA out, so these are the DMA pointers, call jump and stuff, FIFO put get and stuff, FIFO cache graph in FIFO. You get this exception, and so that is nice and all. The strange thing is this exception I could never, the data in here looked reasonable, but from the data here I could not see why the command crashed. Maybe it's off by one, I don't know, but it didn't make, it looked valid, but it didn't make the most sense to me. And the bigger problem with this graphic exception is that I have not found out how to recover from it, right? So if I do RSX program, which is also why this stuff is so freaking time consuming and rather demotivating and depressive, is that each time we got this, there's also an interrupt somewhere, each time we got this graphic exception interrupt here, the RSX would be deadlocked, right? You could do nothing with it anymore. So each time you program and stuff, and then the shit deadlocks, you don't even know or crashes, you get a graphic exception. Most likely your Xorg didn't deadlocks. I tried a couple of things, but I could never get the RSX to reset. I tried a couple of things. So maybe we need to close and open it. So what I have not yet tried, so the last, maybe there is some, maybe I should reverse engineer the hypervisor more without reverse engineering the hypervisor, which maybe I should, I'm in contact with some people who did some reverse engineering. The problem is that most of the reverse engineering people also don't want to have something to do with it anymore, because some were sued by Sony and stuff, or otherwise don't want to see it anymore for all the negative reasons. So without reverse engineering the hypervisor, it is random guesswork. The next thing we could try is close the hypervisor interface here. That is, do we have that here somewhere? Somewhere is LV1 close, LV1 GPU and stuff, right? Maybe this FP close, whatever. So I've not tried that. So maybe we can revitalize RSX GPU by closing and opening it again, but we would need to set up all the memory mappings then again, whatever. So long story short, it's complicated. And so yeah, that is why that work was a little bit annoying to say the least. So that is for another day, unfortunately. But yeah, we're getting there. So also obviously slow is faster. So actually making sure each of the patches is stable one step at a time is obviously. I slightly wonder why this failed there. Exceeds match, whatever. I'm just building here some new stuff for obvious reasons. So yeah, that's basically the summary. Any books that I recommend? Yeah, books is always difficult to get 1% of your low-level hardware. Yeah, it's always difficult. I mean, in modern times, I would just read the kernel sources, like read Mesa kernel. I mean, the problem is books are even often outdated. I mean, maybe some general system architecture and then read some Linux kernel, Mesa, and or BSD sources and go from there. Someone says they don't think that implementing Wayland is possible. Of course it's possible. I think maybe even Wayland is... I need to check, but I think Wayland you in the meantime can run on any mode setting driver without hardware installation, right? So having some simple Wayland running would potentially be as simple as only having a mode setting driver, right? Need to mode setting DRM driver, that doesn't even do much, but Damian agrees, it's around 4% for sure. Yeah, so that is that. On this channel. Okay. Damian says it's even on 1080p, it's even 4 to 6 freaking %, right? So it's a really stupid design decision when, last but not least, as I mentioned before, when you never want to read the freaking frame buffer, right? So just don't read the frame buffer, right? You only blit into, you only write into the frame buffer, and if you need to blit something, then in the Xorg driver pre-blit that locally, and then like basically have a shadow frame like partially or whatever, like do it in X, do it in user space, don't waste your, and for sure not waste your resources to constantly blit half a gigabyte a second without any single pixel change. That is just silly. Comment there, implementing Wayland requires low-level understanding of the GPU, which we don't have. We have full understanding. That is everything reverse engineered. It's just an NVIDIA CPU, and if we run other OS++, so this is just an NVIDIA. We could have, if other people, I mean, there was a proof of concept X driver, which I also revitalized. It just required a couple of more people to constantly, like, to implementing some stuff, right? We could have, if we wanted to, we could have since 2011 or when it was, we could have 3D for over a decade if just some more people took out their keyboard and coded along at home. That's what we are here for, making P3 Linux great again. And we have full understanding. The only thing I don't know, so it's just in regular NV whatever 40, NV, or do we have to say NV4? It's just a previously known NV47. We have full knowledge, and since other OS++ we have full access. So it's a G70, G71, previously known as NV47. It has some cell extensions, which I don't know if they are reverse engineered, but probably they are. I said it before, all the other, many other secrets we can probably derive from RPCS3 if just we had enough time and money. And and getting it to work without crashing, right? I had it working, other people had it working 10 years ago, partially a little bit. So what actually, to be fair, the other people had it like Iron Peter and whoever, they had it working with the hypervisor security vulnerability, right? It does not just work, like I probably was maybe the first who ported the original old like security vulnerability before, when the hypervisor had bugs and you could access some command FIFO before firmware 2.10 or whatever that was. We already had once partially accelerated X, right? Then Sony closed this vulnerability soon, and then soon after they removed other OS support entirely. It was probably me who was the first who ported that, because due to the nature of accessing this security vulnerability, it does not just work when booting properly with full game access, right? I potentially was probably the first and only, or something of that, maybe, who did that. And I ported that and got this driver mostly to work. And now is the time over the last, over the next years, over the next weeks, month and years, the more you shall like subscribe, YouTube membership, super thank Patreon, or buy me coffee. We make all this stuff work step by step, of course not full time, because I not only have a company, and similar to Elon Musk, I have a company and a open source project to run. And sometimes in between, we also need to do other amazing stuff, not only P3, we need to do RISC-V and Sun Spark and IBM mainframes. So, but in between that, we do all the other stuff. So the other thing is, including, I wanted to test how much better performance we actually get for the compile error here was actually, what does this build? Does this continue? What have we done here? So what I'm currently building here is also this is somehow now messed up. That is of course my 5950X. Cross-compiling, all this good stuff. What I'm testing here is actually another performance improvement. I wanted to see how much performance we gain by running this ELF ABI version 2. That is state of the art and the future since some years. We did not yet switch to that. So coming to you next in T2 Linux is actually probably a new option here. At least for, I need to still think where to put that. Probably here a new option of that sort, because obviously we want highest performance Linux that Sony never wanted us to have. PowerPC ELF ABI ELF version 2 LBI, so that somehow, what did I even copy? This one here, right? Endiness, here I deleted, so no, ELF ABI, something of that sort, maybe default to version 1, need to check how precisely we name that. That is supposedly a little bit higher performance again, so squeezing another % performance out of your precious PowerPC CPU, one performance improving solution at a time. Can we copy that on this installation? So that is ELF version 1, change the current ABI to use ELF version 1, this is the default. Big Endian 64 Linux, or running the default requires. So what I need to test, what I'm currently building is, I mean, not only we probably need to patch Rust and stuff then, But I also wonder whether that will work for 32-bit PowerPC. I'm not sure. I googled that, didn't instantly find an answer. If you know, let us know in the comments below. Version 1, version 2. What even was ELF version 2? Let's make this the same, so that would be ELF version 2. I usually use the same name and then I can pass it one-to-one directly through to the relevant configure options and stuff. ELF version 1. I mean, we can if it works. Yeah, I need to basically check what works and what doesn't. I had hardwired this an hour ago here too. So that's basically the other topping on our ice cream here, on our precious code of making P3 Linux greater and improving other open PowerPC performance with the simple tricks. I have hard-coded that to ELF version 2 for a test build, and I'm awaiting the results to test. So that's it for this video. Amazing that so many people tuned in. Don't forget to show some level of appreciation by sharing, liking, and subscribing. And maybe Patreon, go buy me coffee. Hope you enjoyed this, learned something. Have a good day or night. And take a quick look at the last comments. Thing there, people think old NVIDIA GPUs don't support Wayland. I'm pretty sure that should just work with Novo. I would not see why it should not. If you have a Novo mode setting driver, Wayland does not need much to show you some root window. Yeah, patches welcome. Share, like, subscribe. Try it on your P3 at home. Maybe can tackle it for the PhD. Hope that would be acceptable somewhere for a PhD, but always look for your personal success first. The community, the open source community, usually as seen here, does not thank you the most. Xandroids 201, last hardware. There's some open widget shit. Can this also disappear? Either I have here. Where is this open widget thing coming from? Can really not. Modern web stuff, always some random stuff going on. Oh, come on. Whatever open widget is hanging around there now. Anyway, not sure if there was something for PS3 firmware list 210 for sure fixed. I don't remember if some 2 was it 210? Ah, yeah, right. 210 was there, right? Whatever, I guess. Anyway, hope you enjoyed this, and to see you soon for all the next amazing stuff to come. Question there, is it too early to ask when T2 ISOs will be available? Yeah, probably. I will check out the good question. I will check out the performance impact of this ELF version 2 stuff, if it is any faster. Oh, this also errors out already. Is this which build even force that? Okay, this errors out now. So maybe glibc needs some more enablement. So we don't need to rush it the most, right? So probably we wait for some minor versions here. Linux kernel Mesa, we do some last minute testing, I would say, and probably target does it also can be whatever. replace battery in your AirTags tracking family. Yeah, so basically maybe we start the finals like maybe like next week, like basically end of this month, right? So do some more testing, do some more performance like evaluation here of ELF version 2 ABI. Whatever is going on here with probably glibc wants to be configured slightly different. The usual stuff of it just doesn't build. So probably here, so it wants, so yeah, version 2 ABI is not compatible with. So let's see if we quickly, as one last glibc here. Oh, thank you very much. 1.9 this here of. By the way, we could save some energy and probably, oops, shut this down. And so what even was ABI equals ELF version 2? Maybe we at least move this object here out of place and we can better grab. So somehow ELF version 2. Here is some libc. Here is some PowerPC 64. Okay, so apparently that's of course a little bit unfortunate then for multilib if this is only supported for PowerPC 64. What precisely do they test there? Apparently this doesn't work, I guess, unless it is not impossible that here's default ABI, config var default ABI. Whether the compiler is using PowerPC, what do they try if call ELF egrep CPP? It is possible that I worked around it previously, because I remember that once upon a time this did not just build it. Maybe I patched something. Package develop. Okay, that is that. That is because it is a challenge if you have so much grown stuff. ABI, C-Sky, so much quirks and hacks. Anyway, P3 Jupyter, of course. So yeah, somewhere between all this patchery, wherever that is, why would that fail now, although this makes a live stream? Wherever that is, maybe we check the actually here is, oh wait, is this the right? Where am I even? No, glibc. Why do we have here with ABI ELF version 2? Where is it even coming from? This is the, okay, that is just the GCC test. Here is checking whether the compiler is using the PowerPC 64 ELF version 2 ABI. And it thinks somehow not for 162, maybe we, but this was already, we don't get this more precisely, do we? I mean, for a quick test, I mean, we could also basically run our compiler for quick test PowerPC 64 T2 GCC DME misc archive hello C ABI. What did it check? Elf, but it has call elf2. Is it not what it checked? Unless did I? What was the precise version 2? Let's maybe check if we somehow work around it somewhere. Not on first glance. I mean, I remember once upon a time actually work around something like that. They check for if call elf equals, so maybe they run the wrong CPP, because it looks like it should work, but it doesn't. Call elf, whatever it does. Side question, no way to go, just wondering, would it be also possible to write frame buffer driver that would use SPUs? I mean, you can write a lot of stuff. The thing is, the frame buffer driver doesn't give you anything. I mean, you can, but it doesn't make sense, right? The SPUs do not really have much to accelerate there, right? You can, however, write video, decode, encode, helper stuff, and people have done. There was MPlayer stuff. There was even a 3D. There was even some Mesa 3D driver thing that accelerated some 3D or whatever stuff. I believe it was Mesa, right? So yeah, there was like 15 plus years ago, there was some Mesa version that accelerated some 3D stuff on the SPUs. But I mean, it doesn't make the most sense. You can, I mean, it made some sense when you couldn't use the RSX, but now that we can access the RSX, we should make most use out of the RSX and still use the SPUs for other video. You could accelerate MP3 decoding, right? You could accelerate H.264 and H.265 encode decode on the SPUs, where that is for the frame buffer. You don't really have much to accelerate there. You want to put code that does some multiplications and like single instruction multiple data stuff. I slightly wonder what they do there that this fails. What precisely do we run there? We run with that. It should have, what is our CPP? Maybe they run, I have no idea if they run the wrong CPP there, because it kind of looks to me like this should work, unless let's maybe the wrong directory. I hate when stuff behaves so buggy. It should work, but it doesn't. Okay, does this configure log document how it runs? What did it actually is there it documents some stuff, right? So but not here. Wonderful. So here it doesn't document what it did run. Thank you very much. Unless we do, maybe we remove that. Because I remember I work around something. Maybe I work around it. This is not impossible. When you work around something, but a year later don't remember where you work around something. Anyway, I will figure that out. Again, amazing that so many people tuned in. And I hope you learned something and see you soon for the continuation of this fun to come.